So I will not present complicated diagram or technical infrastructure today because my colleagues already did it this morning very well. We did also during other presentation in the past. I will more focus on finally what we do on a daily basis when we operate a DAM network and what we implement to finally have some resiliences and have some peaceful time when something happens and we are not obliged to immediately run because there is no service. So, to start, alors, ça marche pas. Ah, voilà. Alors, to start, just a few numbers to give you a picture about what we are doing. So we started more than 10 years ago, and today we operate 59 DAB ensemble over 3 countries. And we have about 650 service on air, different service. Okay, sometimes it can be 700. It's moving depending what's happening with the customer. In Switzerland, Digris is providing local coverage. So it is basically small SFN that go up to 7 transmitters for one SFN in one area. And DAPCOM is another layer. So in Switzerland, they have decided to call each offer in DAB a layer. So you have local layer, national layer, the public service layer, the private one, etc. And DAPCOM is providing a coverage over the whole French-speaking area of the country. And here it's an SFN of about 24 transmitter. And in France, we also we are operating some site with partner for local coverage who are usually up to 4, 5 transmitter in a SFN. And United Kingdom, it was the project initiated by Ofcom, small scale DAB. And we here provide our services for license holder when they got a license from Ofcom. And we operate sometime for third party operator their technical infrastructure. We support mixed brand of product, transmitter, encoders, whatever, because we have to. As an operator working in different place, different system, we have to be quite flexible and open. But internally, we have also our own development, and when it is only typically in Switzerland, Digris, here we use our own solutions. Our solution are, we are also working on. We don't intend to build transmitters, but we have developed with a Swiss company called Precision Waves a small transmitter that can provide 6 watt without filter. If you add the mask filter, you can go up to 12, which include all the tools in the transmitter to just connect it directly on an Ethernet port. If you have internet access, you define what multiplexer proxy you want to listen, and you can sync it and run it in your SFN. So you don't need to add a gateway or everything. So that's the very low cost option to fill a gap. I mean, all of you are aware about echo canceling technology for gap filler. Here, the idea was to say, okay, made something very cheap in terms of investment and cost, and just use internet as a small transmitter for gap filler that you can give to a community. They provide the place on the roof of the school or whatever. And the solution is also, yes, 100% based on open digital radio. Digris remains today the major contributor of the maintenance of the code, which is under GPL3. So it can be used, but we have made all a complete integration layer to provide our service. We are 100% IP based. So as the company is not so old, we started 2013, 14 for the service. We decided not to use ETI, even if we built some ETI gateway to ensure we are compatible when we have to work with people with mixed environment with ETI and EDI. And we are 10 staff person in the company, and we have also alliance with partners to provide all the service. Alors, ah, hmm, voilà. Just a quick view of the map we have today over Switzerland. It's not a single SFN. I know it's small, but it's not important to know every site. But it gives you the footprint we have over the country. Okay, you don't see all the transmitter on the south and on the north because I did squeeze a bit the country. So you don't see everything, but it gives you a picture. So we cover mainly the main valley, main city area, and the highway for local coverage. So this general view you have seen, you can imagine it is divided by uh, it is divided of 18 SFN over the country. Alors, let's talk a bit about the site first. We finally, like a lot of company, we didn't reinvent the wheel here, decided to categorize site in three categories. So we have, let's say, the most important one, the type A, where here we have power generator. We have always more than one connectivity to the site. IP connectivity again only. We have redundant equipment. We have, in some cases, backup antenna system, like it was explained before. And this is the site where the importance or the number of people who are covered is a priority. Then we have the intermediate one, where usually here we still have more than one connectivity pass, but there is not necessarily typically a power generator there. And I will come back on that later. And then you have the small site which are comfort or the end of the valley for one small village, etc. And you really want to have a coverage there, so that can be done with low power transmitter. Every site are completely remote controlled and monitored. And we have automatic reporting, we have automatic correlations about alarms, etc. To first ensure that the level one support is able to react and more importantly, inform the customer. Because you can have problem, especially when you have natural disasters. But what is important for the customer is to be aware that something happened. If they know you are working on the case, if they know you are fixing it, they are not aggressive. And they even sometimes wish you good luck, or often wish you good luck because they see the weather is a bit complicated, etc. It's not an easy task. So that's also important to always know what's happening on your network. Monitoring remains a key element here. So in case of breakdown, so site intervention, let's say that, okay, we have to physically go there. Let's say the backup and everything is not there, or the site is even not anymore there. Maybe you heard during the last 2 years in Switzerland, we had some important natural disasters. And okay, in some cases, the infrastructure is it's not possible to put it back like this. So we try to access the site by any mean. And we have provisioned different type of solution to have a quick signal re-establishment. Typically, we have possibility to run a small transmitter system with a mast and antenna on a trailer that we can easily bring somewhere. In the future, we even plan to have a van because we had the possibility to purchase a van with already a mast, 10-meter mast, etc. on it, so we could also use that for different action. We also use that for special events. Sometimes you have to provide the coverage for a specific event. It's also used for that. So the equipment you can use for your residents can also be used for other services. We have also fly case with kit ready to go on site in case of needs. And that's also an option to add a transmitter somewhere when you have typically a valley which is interrupted. You cannot cross the valley anymore. You have the phone system, which is usually today in Switzerland. They are talking to increase this value. There is discussion in Bern, but it has been, I think, already acted. But you have, let's say, after 1 hour, not anymore cell tower working. And here you can imagine to give a transmitter kit with satellite, IP, antenna connectivity, or radio link, they can bring into an helicopter somewhere and they can then address the population with this temporary solution. So that's also something we are doing. And yes, important to have a spare part in your inventory, not just complete transmitter, but in 2020, in 2020, when COVID was at the peak with problem to move for people and also goods, we were happy to have LDMOS, fans, spare fans, etc., to maintain our equipment during 1 and 2 years. Because when I was ordering from NXP or Opleon or whatever RF component to repair transmitters, we had lead time of more than a year sometime. Mainly because people who had a lot of money and not anymore able to invest on real estate or whatever, they were buying stocks of electronics to make business with that. So when you have a crisis situation, there is effect with, there is always side effect here. Site connectivity. So as I said, we are full IP, ABC, that's the classification. And we use whatever technology we can find in one area to connect the site. But when it's possible, and most of the time it is, we install our own radio link to have our own IP network. So yes, we use internet. Yes, we use sometimes lease line, whatever we can get. But it's important when you really control most of your distribution network. So we mainly use radio link for that because we are lucky with the mountains. We have always good line of sight position, so we can connect that. And we use dynamic routing protocol, so mainly USPF here. Not only that, but this one is one of the main ones we use. So every site is also part of a node in the national network and part of the backbone. And we have a mix of loop and mesh structure in the network over the country to secure access and remote control and EDI stream. All the low power consumption equipment, we put it on an uninterruptible power supply. Modulator, for the reason you already explained, to avoid to wait too much time to resync GNSS constellation. And a network, because we want to keep the site, even if there is no electricity on it, to feed the other side, to keep the security. It's not because you have one problem on one point, you should create too much problem in cascade. And also because it's important to know you have no electricity on the site. Like this, you know who to call the company who provide the electricity locally to know if it is a long problem or if they are aware or not, and then you can take actions. So just the fact to know there is no electricity on the site is already a very, very important information. It's very simple, but that's important. The timing chain, when you do full IP and you build your network, it is important to take into account your structure because you have latency to manage. And you have the transmitter processing time, you have the transport, you have the different buffer on the between different process. And it is really important to take that into account in your design. And typically an example, if you use OSPF to reroute a route and you configure in your router, okay, I wait 1 second before to take a decision to reroute. Okay, if you don't take that into account in your buffer, your test offset, your etc., I mean, you will have a glitch. So just to tell you that it is also part of the design on the resilience, you have also to think about your timing chain from the beginning to the transmitter. We do a lot of internal software development. And so since the beginning, we had to develop our own EDI gateway because when we started, SRT was not there. And we did use different protocol and different tools to make sure we were running in SFN. And the main problem was to make sure we are second aware, or we know we play on the right second. Because historically, when network started, especially in ETI, the network was designed to make sure you were on the right second. As soon as you are asynchronous on your line from your head end and transmitter, but it's true also from studio for audio to align audio sample, etc., with audio over IP. I mean, you need a real good clock. So then the question is, you have to care about that. I will also go back there. Um, the network end, okay, everything is virtualized. Um, and we use a secure data center with geographical redundancy. That's the first thing to do. Then virtualization cluster allow us to be very flexible. As we are mainly software-based since the beginning for everything, that was really easy for us to think about that from the beginning. We don't use cloud service. The reason is because we want to manage. I mean, it's not because we are virtualized and we work like a cloud service finally. It is our cloud or it is our infrastructure, and we control it and we decide what are the priority and how we design it. I don't say you cannot run a multiplexer on commercial cloud. But the question is, what about the environment? Will they give you guarantee over 10 years for the same setup, the same things, etc.? So meaning you don't really save time, and more you are using CPU, etc. The costs are not also so low at the end. So finally, making the effort to build your own cluster, it's good. And high availability is also interesting for maintenance. We don't use high availability, so the fact that you can move a virtual machine or a container from another host without switching it off. We don't really use that. We have also redundancy everywhere. But just to play, we tried. And I tried on a DAPCOM layer to move a MUX when it was running in operation. And we had absolutely no glitch, nothing. Because the timing we put, the buffer and everything, was long enough to avoid that if we had a slight delay. The only thing, there is a trap. Don't be too, I mean, you should wait a bit if you just install a new host because you had a problem and you move a VM on it with a high availability system. Just wait that your host is well synced. Otherwise, you may have trouble. But otherwise, yes, it's working well, even for DAB, to use this kind of IT concept to secure your system. Network core, yes. So we have also redundant router, duplicated infrastructure, as you have seen on schematic this morning. I don't go too much there. We also make backup. So there is a local backup every night. And every week we do backup on a third site. Like this, if we have really a problem, we were talking about cyber attack risk, etc. So let's say there is really something really critical, even if we take all the measure to avoid that. Let's say we have also not only hot backup, but cold backup somewhere else, where we can switch back some service from another place, in addition to the main two data center. And the retention of information is 4 months. At that moment, we decided for that. We are also pairing with, we choose carefully provider for internet connection in data center and different place where we are important point because the goal is to minimize the complexity of the route to have always the shortest route. When we started, as I said, SRT was not there. So Matthias Brenly, who is there, had a very good idea to say we could use ZeroMQ, which was a library available in Linux, running on Linux system, to encapsulate finally the EDI stream and to have a useful, a reliable transport. ZMQ works fine. You can even encrypt if you want, but we finally decided to move to EDI TCP because not because it was not but because we started to see some people thinking to implement ZMQ into transmitter. Then I said, you remember the story? You said, yeah, maybe it's not a good idea because we should stick to some standard here. Maybe it's better. So that's the only reason. So we still support it in the Open Digital Radio solution, but at Digris, we don't use it really anymore. And the EDI gateway include also time check for second hour, as I explained before. And there is also the concept, as you have also presented in different solution, to have more than one source. So you can do a multi-stream bonding, reconstruction, etc. To make it even more reliable. We support also satellite protocol transport because we have some radio station we retrieve via satellite. We can also support that. It was also a test with GSE, MPA, all these things. we don't use satellite us to distribute our signal, not because we don't like it, but because, as you have seen in the first slide presentation, the number of sites we have per SFN is not so high. So yes, we have a lot of MUX, a lot of service, but we don't have very national-wide large SFN. So the cost of a satellite contribution, let's say, network is not really relevant here in the business model for this amount of sites. But again, it's our case here. SRT implementation has been also used now here, like in DAB Italia, and we call it today proxy. It's also to receive stream from other operator or other customer. And otherwise, we have also MPLS tunnel with different operator. Typically, when you have to exchange in EDI, you have to give to somebody your EDI from your MUX because the site in a specific coverage, for example, in France, you have some site that can be TDF, Towercast, or some site we do us with partner. And they have also customer already encoded, so they give us the EDI from the DAB encoder. So yes, we have also to accept this stream to exchange between operators to make the life of customer easier. Like this, they don't have to each time, oh, it's another operator, I have to add an additional encoder, we have to redo all the metadata stuff, blah, blah, blah. So we have also that in the head end. Signal contribution from station. So we support remote encoder at the radio station. And here we had the Digris Audio Companion. It's a small appliance, which is, it can also run as a virtual container, who mainly control the DAB encoder. So typically we use a lot of AVT encoder here. And we told to the encoder, we manage the pad of the AVT encoder with their API, and then we can send to our head-end reliable stream contribution. And it is since a long time like this. It was one of the first external encoder we did support in the solution. We also support audio contribution via stream, can be loosey codec or linear one, whatever they give, satellite. We even have some customer who are sending us via satellite a national contribution or let's say an international signal, and then they remotely switch to some local content. They remote control on our place some local content to have local content at some specific period of the day. There is always more than one source, which is configured for a radio station. We don't have really a limit here. You can define 1, 2, 3, 4, 5 sources, and then you give the priority. You can also force a source exactly to avoid some time because you have a default strategy to say, okay, if I lose the top priority, I take the second one. When the top priority is back, how many times you want to wait before to go back to the main one? So you can define a default one in accordance with the request of the radio station. But then if there is really a situation where even that is not good enough, then you can say, okay, I force it, and then I wait the customer tell me they have finished the work on their side to force it back to what they want, or to automatic. EDI source, yeah, I explained already. Alors, SRT listener, yeah, we support also SRT listener for specific contribution. Metadata, timeout detection, yes. We talk about radio station, there is this metadata with that, we have to sync it. It's also good to know when they are not working. So we also implement timeout here to have alarms and in order to warn the customer because they say we don't have any more your metadata, or maybe we have a problem. So there is also alert on the metadata. It's not only audio, silence detection, etc. Time reference. That's the last point here on the topic. All of us, we use mainly GNSS to sync everything, mainly our transmitter on site. And we have seen since, especially, I mean, here in Switzerland, since 2022, that we had some time problem here. We had signal jamming, etc. during some event, mainly because military use that to limit missile precision or to avoid drone, let's say, navigation, etc. And the question is, what will happen in the future here? is it really safe to just have this source to sync everything? So I don't have here an easy answer, but we are thinking since a few years now on this topic to say, okay, what should we do? Okay, we can build a network to have a time transfer function. Okay, we can do that. What are the costs? Maybe that's the solution. Or maybe we can broadcast a terrestrial clock system, because finally the information you have to send is not a huge information. It's a very small amount of data, but you need to have precision. So you need to use mechanism here with specific modulation scheme. It can be very low bitrate modulation scheme. It can be very robust. It can be different frequency band to do that. But let's say here there is a reflection we have to say, should we make something? And with the technology today, it's very easy to make a proof of concept at low cost to validate modulation protocols and to test it with SDR platform. What we have seen is during our last 12 years of operation, we had a few time problem with that, not because of jamming, but mainly because of lightning, and it did destroy the GPS antenna or the RF distribution splitter or the master clock somewhere on the site. And usually they are quite good. I mean, we use 4 brand of transmitter in our network, and we have seen that we have often a good performance between 12 to 56 hours where they remain acceptable to maintain the SFN. But it means for that you have to monitor them, and also it means for that you should not switch off your modulator. So that's why it is important to have always energy here. But when equipment is aging, usually these figures are getting worse than it is when they are brand new. Some brands have some learning mechanism where they compare versus temperature, the behavior of their oscillator, etc., local clock. And they are quite good at that because they in fact follow the aging of the internal reference. And I must say that the brand who are doing that, we have after 12 years, we have now some good experience. We see that we can really count on that. So it means for us, it gives us just enough time when we have a problem on the site with that to access the site. I'm not talking when the weather is nice like today. I'm talking when you have really a problem on the site or a storm, there is damage, and you have to wait 3 days to access the site because no helicopter can fly, no access from the road. You cannot hold the cable car, there is too much wind, so you cannot switch it on. So that's, I can tell you I had a few times in the past, I was looking on the monitoring and the clock and the value remaining in theory and seeing the time and to find the weather window to access there to fix the problem on site. But until now we were lucky. So that's it.